looking at question 27 out of chapter 7, it asks about a sampling distribution where you have a machine with 45% of its candies are as orange pieces. We sample 25 pieces of candy and want to know how strange is it to get 8 orange ones. Well, looking at this graph, 8 orange ones out of 25, that turns out to be 32%. That's right down in here. Whoop, let me get my color. In here, that's the number that had 32% or fewer. That's quite a few of the options or of the dots on there. That's not really all that unusual. On the other hand, if we only got 5 oranges, that's 20%. That's just these down here, just these dots here. That's not very likely. That's much more uncommon. We should be surprised to only get 5 pieces of orange candy. Now, part B really gets to the heart of the matter. It says, is it more surprising to get 32% orange out of a sample of 25 pieces or out of a sample of 50 pieces? So let's look at both of these cases. This graph that's on here now is the one that has a sample size of 25. And to get 32% orange here, again, you'll recall that was this section of the graph. Now, looking at the picture for a sample size of 50, 32% or less is this side of the graph. You can see here that this graph is much more compressed. It's gotten a lot, the standard deviation's gotten a lot smaller because my sample size has gotten bigger. Since the standard deviation has gotten smaller, it's more unusual to get the more unusual cases. So the answer for part B is the sample size of 50 makes this somewhat more unusual. Hope this helps clear up how sample sizes affect the sampling distribution and therefore affect the unusual cases.